If I'm allergic to seafood,
and we see the sun from Earth, and it makes the Earth bright.
How come hot air gets cold?
In this video, I'm going to be answering some fun science questions from Reddit and TikTok. Starting off with this video.
How come hot air get cold when fan? How come fan make hot air in room cold? It's just fan. It just spin. You know? How come hot air in room go through fan get cold?
A fan doesn't cool the air, it moves it around. What actually cools your body is the combination of convection and evaporation, and the fan is just helping both of them work faster. When your body is hot, your body sweats, and this sweat absorbs heat from your skin to evaporate. But if the air around you is still humid or hot, the sweat just hangs there and does not go off. The fan then blows the air across your skin, helping the evaporation work faster. This evaporation removes heat, and then that cools you down. Your body naturally radiates heat into the air around it, but if the air is not moving, then all the heat is trapped, basically forming a bubble of air around you. The fan blows that hot air away from you and then replaces it with colder air, increasing the convective heat loss from your skin. So in summary, body hot, air around body hot, fan spin, air around body move, new air not as hot as previous air, body feels colder. Moving on, this person asked on Reddit, if a laser's light only travels in one direction, then how can I see the beam? This is actually a very nice question, because a laser beam is supposed to be a focused stream of light, so how exactly can you see it? Well, the answer is simple. You see the beam only when some of that light gets scattered into your eye. This happens when there are particles in the air like dust, smoke, fog, mist, or even humidity that gets hit by the laser. These particles scatter some of the light and it falls in all directions. Some of those scattered light enters your eye so you can perceive a glowing beam in the air. So if there's no particle in the air, then there's nothing to scatter the light into your eye, which makes the laser invisible except when it hits its target. Also, fun fact, in a vacuum of space, a laser not pointing directly at you should be completely invisible due to lack of object or particles for the laser to bounce off. So the real question is, if there's an alien species out there currently having Star Wars type battle, how would you be able to detect it? And the answer is, if the beam is not directed at Earth and it's a laser type beam, then we will not be able to detect it. The only way we might be able to catch something is if we detect thermal signatures like heat or explosion from ship engines. The next question is,
and we see the sun from Earth, and it makes the Earth bright. How is space not bright?
This is actually a very simple question. Space is dark even though the sun is in space because light only light up things when it hits something. And just like lasers, the light needs something to bounce off in space for it to create the light effect or brightness. And there's almost nothing in space for those lights from the sun to bounce off, which is why space appears black. You can see the moon and other planets because the light from the sun is bouncing off them and then towards your direction, creating the brightness effect. If you are enjoying this video, please consider subscribing to the channel so you can get notification when other videos like this come up.
Also, I used to think that iron that's in cereal was iron. It is. Is it?
This is a relatively simple question. Yes, the iron in your cereals is actual iron, just like metal. As a matter of fact, it's tiny bits of metal, just like nails, that they grind into superfine dust and then add it into your cereals. Your stomach acid helps to break it down so your body can use it. It's just like sprinkling iron powder on your food. It's not dangerous for tiny amounts and is actually good for your blood because your blood needs iron.
If I'm allergic to seafood, can I still scuba dive? Or is that like fish juice and I'll go into anaphylactic shock under the ocean?
Yes, you can still scuba dive. One, because the ocean is big as hell, and there are not enough items in the ocean to make it a fish soup. And so you technically be protected by your scuba diving material, so you will not have to worry about taking in liquid from the ocean, which wouldn't even matter because the ocean is not a soup. Moving on to the next question. How do we take those fancy pictures of the Milky Way? We cannot fly outside of our galaxy to take pictures of it. We lack both the resources and time for that. So how do we get these pictures? The answer is, they are not pictures, rather they are artistic renderings. See, images like these and these are taken from within the Earth using long exposure, but images like these are artistic renderings or computer generated based on where we think we are in the galaxy. And from observing similar galaxies close to us like the Andromeda Galaxy, which is our closest, biggest neighbor, we can depict how we think the Milky Way could look like or actually looks like. We know the position, color, and brightness of over 1 billion individual stars in our galaxy from multiple directions around the Earth. That's only a small fraction of all the stars, but it still gives you a pretty good idea of the location of various objects in the galaxy in relation to us and each other. Feed that data into a computer and it can generate an image from any viewing direction you want. Will it look exactly like the galaxy from outside? No, but it's close enough to be useful. Moving on, what if the Earth was replaced by a black hole? This question has been answered multiple times here on YouTube, but this time we will be given estimated time periods of the timeline of events. As long as the sun or a black hole remains the same mass, it will have no effect on the planetary orbit, which means the planet will continue to orbit around the sun/new black hole the way it did. It will no longer produce any light and will probably be too small for you to even see with your naked eye because it will only be around 3 kilometers wide. If the switch happens instantaneously, then you would not even notice that the sun is gone until after 8 minutes, because that's how long it takes for light from the surface of the sun to get to the Earth. After that, the solar system will go into perpetual darkness and the planet will start to freeze. Within the first few days, temperatures will start to drop across the globe. The reason it will not drop in one instance is because the Earth has thermal momentum and the ocean and the atmosphere also stores a lot of heat, so that will act as a reserve. After a week or so, the plants relying on photosynthesis will start to die out because they can no longer get light from the sun. The atmospheric reserve of heat has run out and the temperatures will start to drop below freezing points in some places on Earth. Countries closer to the poles will feel this more than others. In less than a month, every life on land is gone and the ocean will start to freeze over from the surface. After a year, the Earth would have a temperature close to 240 degrees Celsius, negative 240 degrees Celsius, and the only form of energy left on the planet will be from geometric activities. The planet would have frozen into a complete wasteland. If you would like to make any corrections to anything that was said in this video, be my guest in the comment section. Also, please like and subscribe.